Hi, this is Dr. Bitlavenu coming in front of you. A new chapter, new subject, that is engineering drawing. This engineering drawing is the basic core subject for all the mechanical engineers. Basically, it's a core subject for uh, the civil engineers, mechanical engineers, and then almost all the engineers must be able to draw and the basic concepts related to the engineering drawing. That's why I have chosen these subjects to present, which is useful to all the engineers. In today's session, I would like to discuss the conic sections. Every component, every drawing, like civil drawing or the mechanical drawing, will be composed with all the curves. So in this section, we will see the different sections with, different curves in which we have the conic sections. Let me move further to see what is exactly the conic section, how we can get and why we are calling the conic section, and how we can get different types of conic sections we will discuss in this session. Let me move further to see what is conic section now. Okay. In this conic sections part 1, we will discuss the basically conic sections are 3 types. I will discuss in detail how these 3 types we will get and what exactly the procedure to get these 3 types I will discuss in the next session. Basically, conic sections are 3 types: ellipse, parabola, and hyperbola. Again, ellipse is classified. Ellipse can be generated in different methods. There are different methods to generate ellipse: concentric circles method, rectangle method, oblong method, arcs of circles method, rhombus method, and basic locus method. In the coming slides, in the coming parts, we will discuss. In the next session, I plan to discuss the parabola. In the next session, I also plan to complete parabola and hyperbola. Whereas in this session, I would like to discuss the different methods to generate ellipse. Now let me move further to see what exactly the conic section. Conic sections, as I said just now, there are basically we will get 3 types of conic sections: ellipse, parabola, and hyperbola are called conic sections. So these conic sections will be formed when we cut a cone. These sections are formed from cutting a cone, so that we are calling these sections as conic sections. Example, ellipse, parabola, and hyperbola are called conic sections because these curves appear on the surface of the cone when we cut that cone by some typical cutting planes. When we cut a cone by using a section plane, when we cut a cone by using a section plane, the surface that we get, the shape of the surface that we get may be ellipse, parabola, or hyperbola. Now let me move further to see how we are going to get these shapes. Uh, Observe all these illustrations here. Assume one cone here. Take one cone here, and a cone is having, because we have an axis and it is also having a base, then it is also having the generators are the slant lines. As of now, you try to understand here, the slant lines are the generators. Because of this generator, when we revolve this slant line about this axis, we will get this cone. So that we are calling these slant lines, in this case we are calling as the generators. In different cases, we are taking one section plane. We will make this cone in section in different directions and different methods. We will get the different shapes. To get different shapes, so those shapes are in turn we are going to call as ellipse, parabola, and hyperbola. Now let us see in the first method and the first type, we are cutting this cone using a section plane in such a way that that section plane is cutting this cone uh, by passing the 2 generators. Now you can see here, you have a section plane here, and this is cutting in such a way that it is touching the two generators. Now you can see here we have two generators. This section plane is touching the first generator and the second generator. That means two slant lines. This shape, the section shape that we get is this one. After making the section, we will get one shape here. So that shape is nothing but ellipse. When the section plane touches or passes through the two generators, the shape that we get is ellipse. Now let us take one more case. Consider the cone, then we have an axis here, then section this cone which is parallel to the one of the generator. The shape that we get, the shape of section that we get is parabola. It is having definite shape. Now you can observe here the shape of the sectioned surface. Here the shape of the sectioned surface is different. So in the first case, the section plane is passing through the two generators. In this case, the section plane is parallel to the one of the generator. So the surface that we get is parabola. The surface that we get is in the shape of ellipse. So ellipse and parabola. Now let me move further to see. Take the cone again. Then in the third case, we are making section. So the section plane is parallel to the axis of the cone. The surface that we get is like this, and this shape is called hyperbola. You can see here. So the shapes in three cases, are entirely different. Now you can see here. When the section plane passes through the two generators, the shape that we get is ellipse. When the section plane is parallel to the one of the generator, the shape that we get is parabola. When the section plane is parallel to the axis of the cone, then we get the shape. That shape is called hyperbola. So ellipse, parabola, and hyperbola. So these three shapes we are getting by making sectioning a cone, so that we are calling these shapes as conic sections. By making section, we are getting these shapes, so that we are calling ellipse, parabola, and hyperbola, or in turn we are calling as conic sections. Let me move further to see the different types. As we have seen, ellipse, parabola, and hyperbola. So before going to that, these curves as having some basic rule. These curves are forming some basic rule. So that basic rule is that, so the locus of points moving in a plane, all the locus of the points means we will get all the points when we connect all those points. So that is called locus. When we join the different points, we will get a curve, we will get a path, we will get a shape. So that shape is called locus. Locus of the points means when we connect the different points, we will get some curve. Okay, that is called the locus of the points moving in a plane such that the ratio of its distances. That means we are moving a point in a plane such a way that the distance of this point from the fixed line and from the fixed point remains constant. That means the ratio of the moment of the point, the ratio of the distances from the fixed point and the fixed line remains constant. Okay, so here the fixed point is called the focus, fixed line is called the directrix. We will discuss what is focus and what is directrix in the next slide by taking an example. Okay, so here the eccentricity is nothing but the locus of the locus of points moving in a plane such that the ratio of its distances from a fixed point and the fixed line remains constant. So the ratio is called here eccentricity. Here, what is eccentricity means? So the locus of points moving in a plane such that the ratio of its distances from a fixed point and a fixed line remains constant. Ratio of distances of a moving point from a fixed line and fixed point is called the eccentricity. If this eccentricity, if this ratio of distances is less than 1, so we will get an ellipse. Ratio of distances means fixed point distance and fixed lines distance to a point. The ratio of distances to a fixed point to the fixed line of a point is called the eccentricity. If the ratio is less than 1, then we will get the ellipse. If the ratio is equal to 1, that means the ratio of distances of a point from a fixed point to the from a fixed line is equal to 1, we will get parabola. Okay, so then if the ratio of distances from a fixed point to the fixed line is greater than 1, we will get hyperbola. We will see these three in the coming slides. So what is eccentricity? What is the terminology associated to draw ellipse, parabola and hyperbola in the coming slides? Okay, so then let me move further to see an example. Let me take an example to see what is focus, what is directrix, what is major axis, minor axis. We will discuss in this slide. Okay, so let us take one example. So point F is 50 mm from a line AB. We have one point F, namely that point is F. So 50 mm from a line AB. So a point is 50 mm from line AB. A point P, so this is F point, a point P is moving in this plane such that the ratio of its distances from F, that means fixed point, and from B, fixed line, remains constant. So we have point P, the distance of this point from F, and this point is moving in one plane, moving in a plane in such a way that the ratio of distances of this point P to F and P to AB is constant. So the ratio in this case is 2/3. This value is given to us. A point is moving in a plane in such a way that the distance of this point from a fixed point F is at a distance of 50 mm, and this point is at a distance, at a certain distance from AB. The ratio of these two distances is in the ratio of 2/3. So this is called the eccentricity. Now let us see. Here the eccentricity is 2/3. So now he's given some dimension. Okay. Now draw a vertical line. Draw a vertical line first, and you name that vertical line as AB, and mark a point and take a point. So take and draw a horizontal line first and take a point. So this, as I said just now, this vertical line is called directrix. So this is a fixed line, is called directrix in this case. Then mark a point F at a distance 50 mm from this fixed line. So name that point as F. So that is called focus. So fixed line is called directrix, fixed point is called focus. The distance between this directrix and focus is given in this problem as 50 mm. So mark a point F which is at a distance 50 mm from the directrix, that is AB line in this case. After marking point F, so here the eccentricity is 2/3. Okay, so divide this into 5 equal parts. Divide this into 5 equal parts. The distance here is from 50. So here the distance from directrix to focus is 50. So divide this 50 into 5 divisions. Here 2 plus 3 is 5 here. Then here in this case exactly 50, so that you can mark these points 10 mm, 10 mm, 10 mm. Otherwise, if it is different value, you have to follow the different procedure to divide a line into equal segments. Okay, so now dividing this into 5 equal segments, then here the eccentricity is 2/3. That means, so the numerator value is 2 here. So total 5 divisions, you come to the second point. Okay, so 2 distance. So from focal point here, move to 2 distances are the second point otherwise. So this point is called. So as of now, we have divided this distance, that is the distance between directrix to the fixed point focus F, into 5 equal divisions. So in this case, the distance is 50 millimeters, so that it is normally 10 millimeters, 10 millimeters, 10 millimeters. So now the numerator is 2, so that 2 divisions, you come back 2 divisions from focal point. The remaining divisions are 3 that you can see here. So 2 by 3, the distance is the ratio of this point. So now this is called vertex. So after marking vertex point, so 2 by 3 here. So now it is falling exactly, the point P is lying on the horizontal line. That means, as you can see, the distance of this point, vertex V, is the ratio of 2/3 when the point V, when the point, moving point, lies on the horizontal line in this case. So 2 by 3. So now let us see. Let me move further. Okay. So now you take one line. Now you take one line. So normally from more points giving same ratios. So it is the ratio of 20 by 30. Otherwise we can take 30 by 41, 45, then 40 by 60, then 50 by 70, just like that. So now we take, now it is, you would take 30, then 45. So we will get 1 point here. So 30 and 45. Okay. So we take 45 and take 30 line, 30. So draw a line at a distance of 45. Okay. Then by taking 30 mm in our compass, just you intersect this, you will get 1 point here. Now you take 60 mm. So now you will get one point here and 1 point here. So I explain this once again. So after marking vertex V, so take 45 mm, draw a 45 mm vertical line, draw a vertical line at a distance of 45. Then take 30 mm in our compass and F as center, and intersect this vertical line with 50 mm radius. You will get 2 points. Then move further to C. Draw a vertical line at a distance of 60 now, at a distance of 60. Then, so this is at a distance of 60. Then you will get the 2 points here. Now you take one more line at a distance of 75. At a distance of 75, take 50 mm in our compass with F as center and intersect this vertical line. You will get the points like this. So in this way, we will get the points to complete ellipse. So we go on, add lines, vertical lines in the ratio of 2/3 and mark these points, indicate these points, complete this ellipse. This is, and join all these points to get ellipse. Okay, so now the distance should be maintained in this ratio. So while drawing these vertical lines, the distance should be in the ratio of 2/3. So initially we have taken 20 by 30 exactly at this location. This is our first point we are indicated. Then the next ratio is 30 by 45. As you can see, 30, 45. The next line is 40, 60. The next line is 60, 40, as you can see. So up to here it is 60. Of course, it is not mentioned here. It should be 60. Then it should be 40. So by taking 40 mm radius in our compass, just intersect this vertical line. Then you take 75 mm, draw a 75 mm vertical line from the directrix. So take 50 mm radius, F as center, get these 2 points, get these 2 points. So then go on further until to get on the vertical line, until to move this vertex on the horizontal axis. We can get the closed ellipse like this. Okay, so this is what the ellipse, constructing ellipse in general method by taking directrix and focus vertex like this. So from this, so I will repeat this once again. Fixed line is called directrix, fixed point is called focus. Okay, the distance between the locus of a point, this point is moving, as you can see here, this point is moving in such a way that the distance, the ratio of distance between the fixed point to the fixed line, fixed point, here this is our fixed point and this is our fixed line, ratio of this distance to this distance is same. That means this point, this vertex is moving in such a way that the ratio of distance between the fixed point to the fixed line is constant. So in this case, the ratio of distance between the fixed point to the fixed line is less than 1, we will get ellipse. Okay, so now I repeat this once again, this problem. Let me go back to repeat this problem. Then first you draw a vertical line. First you draw a vertical line, name that line as AB. Then draw a horizontal line, fixed line, vertical line, it is a fixed line, is called directrix. Then mark a point at a distance 50 mm, at a distance 50 mm from the fixed line, that is directrix, because in our problem is given 50 mm distance. Our fixed point is at a distance of 50 mm from the fixed line. Okay, let me move further to see. So this is called focus. So here the fixed point is called focus, fixed line is called directrix. Then divide this line into 5 equal divisions. As you can see, 2/3, the eccentricity is 2/3. So that divide this 50 mm, here in this case 50, divide this into 5 equal divisions. Then mark a point at 2 from the F. Now you can see, so total divisions are 5 from F, and mark a point at 2. So 1 and 2. So this vertex is at 2. Now you see this point is called vertex. Now we need to draw the vertical lines after vertex point. After vertex is at this location, after vertex point rightwards. So draw the vertical lines in such a way that the ratio is 2/3. Now you see here. So the first ratio we have drawn, right? This point is 2/3, 2 and 3rd. Now 40 by 60, you take 40 by 60, okay? Otherwise 30 by 45. So that means draw a vertical line with an imaginary length, and this line is at a distance of 45. So draw a vertical line at a distance of 45. From directrix to this line is 45. And take a compass. In that you take 30 mm radius with F as center. With F as center, intersect this vertical line. and as well as. So this distance is 30. So 30 mm as radius in our compass. So intersect this vertical line. And as I said with you, this vertical line is at a distance of 45. Taking 30 mm distance, intersect this line, or draw the curves to intersect this vertical line, top and bottom. Now draw a vertical line at a distance of 60 now. So because we need to maintain, because this point, so this vertex point is moving in the ratio, that ratio is 2/3. That's why I'm maintaining 2/3. So 30 by 45. First we have drawn 20 by 30, that is at this point. Then we have drawn 30 by 45. We have one point here, focal point here, or else vertex point here, or a moving point here. And then it is 60. So this line is at 60 now. Now take 40 mm radius in our compass with F as center. So draw the curves or intersect this vertical line at 2 points, up and down. Now you draw a vertical line at a distance of 75 mm from the directrix, and taking 50 mm as radius with F as center, draw the arcs to intersect this vertical line, which is at a distance of 75 mm, to get points. So totally we have 3 points here now, 4 points. Vertex is 1 here, exactly on this line itself, 2, 3, 4. So three points. So proceed further in this way. So move further by maintaining these distances, maintaining this ratio to complete ellipse. Now you see here, totally we have 4 points here, upper half. So and even from the bottom half of it, so we have 4 points. Okay. So now join these points to get a smooth curve. So like this. Now we move forward to complete. So move forward to complete ellipse until this vertex point, until to reach this vertex point on the horizontal line. So now this is called ellipse. This curve is called ellipse. That means the locus of a point, locus means joining all the points by moving a point in a plane in such a way that the ratio of fixed point to the fixed line, ratio of distances of the moving point in a plane in such a way that it is in the ratio of 2/3. The distance of ratio of the moving point is at a ratio of 2/3. So we will get ellipse. Now let me move further to see the different method to construct an ellipse. So now I read out the problem. Draw an ellipse by concentric circles method, taking major axis as 100 mm and minor axis as 70 mm. Okay, now draw a horizontal line with 100 mm length, then draw a vertical line and 70 mm long. Okay, major axis and minor axis. That means draw the perpendicular bisectors with major axis and minor axis. Now label them or name them as AB, major axis as AB, minor axis as CD. So AB length is 100 and CD length is 70 here. Now with major axis and minor axis as diameters, draw the 2 circles. With minor axis 70 mm as diameter, so draw a circle. Okay, so which passes from CD, right? So draw a circle with 100 mm diameter. That means this will become the major axis. Major axis as diameter. Draw a circle with minor axis as diameter. One more circle. That means we have drawn 2 concentric circles here. So one will represent the major axis and the other one will represent the minor axis of the ellipse that we are going to draw. Now let me move further. Okay, so now divide these 2 concentric circles into 12 equal divisions. Divide these 2 circles into 12 equal divisions. So that means 12 equal divisions, 30 degrees, 30 degrees, 30 degrees, we will get the 12 equal divisions. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, until 12 we will get. These two we are named as AB, so that we are getting 10 only. Okay, so after dividing the circles into 12 equal divisions, so name those points as 1 to 10 or 1 to 12 like this. Then in the inner circle also, so indicate the points. Okay, indicate all the points, so where the divisions are occurring. Okay, so then drop the vertical lines from the upper portion of this concentric circle. Drop the vertical lines from 1, 2, 3, 4, 5 of the major axis circle, upper portion of the major axis circle. Now drop the vertical lines above, vertical lines, draw the vertical lines below the major axis circle like this. Okay, so like this, drop the vertical lines here and draw the vertical lines or the extend the points vertically from the bottom portion of the major axis circle. So after dropping the vertical lines or after drawing the vertical lines from the major axis circle, then draw the horizontal lines from the minor axis circle like this, but exactly here. Then draw the horizontal lines from 1, 2, and 3 exactly, that will coincide at this location. Draw the horizontal line here to intersect the vertical line at this location. Draw the horizontal line from point 5, which will intersect the vertical line of the major axis. Then we will get the point here itself. Then we have already vertical line here. Draw the horizontal line from point 6, 7, 8 exactly we will get at this location itself, 9 and 10. So name all these points. So we will get point P1. Here this is your point 1, 2, and exactly here, here, here. Then all we will get the different points here, different intersecting points here. So by joining all these points, we will get a curve. So draw the, or join all these points in as a smooth curve. So overall curve, we will get an ellipse. So I repeat this once again. For the clarity. So we have the major axis and the minor axis. Draw an ellipse by concentric circles method, taking major axis 100 and minor axis 70 mm. Okay. So now, so draw the two perpendicular bisectors with 100 mm and 70 mm. Name those bisectors as AB and CD. Major axis is AB, minor axis as CD. Then draw the two concentric circles by taking major axis and minor axis as diameters. Okay, so this is your minor axis length, that is 75 mm diameter, and major axis is 100 as diameter. Draw one more circle. Then divide these two concentric circles into 12 equal divisions. 12 equal divisions, 30 degrees, 30 degrees, 30 degrees. So if we draw the 30 degrees lines one after the other, so this 360 degrees will be divided into 12 equal divisions. Now name all those points 1 to 12 here. So in this case we have AB, so that we will get 10 here. So the first point is A and sixth point is B, so that we get total 10 points here apart from AB. Now divide, so now mark the points in the inner circle also. So 1 to 10 here. So here this point is different and this point is different. So now drop the vertical lines. Drop the vertical lines from the upper portion of the major axis circle. Now you can see here. So draw the vertical line from the upper portion of the major axis circle like this. So exactly at this point we will get the same line itself. So drop the vertical lines like this. And similarly, from the bottom portion of the major axis circle also, draw the vertical lines like this. Okay. After drawing the vertical lines from the major axis circle, then draw the horizontal lines from the minor axis circle like this. From the minor axis circles. So these horizontal lines are going to intersect the vertical lines dropped from the major axis circle like this. So now we are obtained the different points here. First point, second, and third we will get here 4, 5, 6, 7, and 8 itself here. That is at this point D, and that is at this point C and D will coincide. Then 9, 10, and finally, by joining all these points as a smooth curve, we will get one shape. That shape is in ellipse. Okay. So now let us see draw an ellipse by rectangle method. As of now, we have seen the general method to draw the ellipse, and the second method we have seen concentric circles method. Now in this we will see draw an ellipse by rectangle method. Okay. Now in this case, in the rectangle method, draw an ellipse by rectangle method, taking major axis as 100 mm, minor axis as 70 mm long. Okay. Now draw the two perpendicular bisectors AB and CD. So name them as AB and CD respectively, and the lengths are because given to us. So 100 mm AB is 100 mm, CD is 70 mm long. So these two are perpendicular bisectors, and complete a rectangle like this and divide. Consider the upper left portion of the rectangle, then divide the height of this upper left portion of the rectangle into equal number of divisions. So say in this case, I am dividing this height into 4 equal divisions. I am dividing this into 4 equal divisions. As you can see, 4 equal divisions. Normal procedure we have to divide a line into equal number of divisions, that we have to follow. After dividing this height of this rectangular block into equal number of divisions, then divide the same number of equal divisions the horizontally also, lengthwise also. So now divide the same number of divisions that we have divided in height. Even lengthwise also divide the same equal number of divisions, that is 4 divisions that we have done height in the case of height. So now join the point, the upper point. The upper point of the minor axis is joined by the vertical points, vertically divided points are the height divided points. Then join the horizontal points with the bottom end of the minor axis. The upper end of the minor axis is joined with the height points. Then the length points, the lengthwise points are joined with the bottom end of the minor axis. So bottom end is C here, upper end is D here. So join all those points like this. The upper end of the minor axis is joined like this. Then the lower end of the minor axis is joined like this. And these lines are going to intersect. So after joining this point, extend this point 1 to intersect, C1, C2, C3. And D1, D2, D3 we got. Then extend this C1 up to D1. Okay. Then extend C2 up to D2. So we will get one intersection point. Extend C3 up to D3 like this. Okay. So after joining, so the vertical distances, the vertical points are joined to the upper point of the minor axis, that is D. Then the horizontal divisions are joined to the lower end of the minor axis like this, lower end of the minor axis like this, and this C1, and extend this C1 up to D1. So we will get one intersection point. Then extend C2 up to D2, we will get one intersection point. Extend C3 up to D3, we will get one intersection point. Now join all these points. So we will get the points like this, intersection points like this. Then join the smooth curve like this to get the some portion of the ellipse. Now repeat this similar step to the right side rectangular block also, like this. Divide this height into 4 equal number of divisions. Divide the width of this rectangle into equal number of divisions that we have done in the height wise. Then similarly, the upper end of the minor axis is connected to the height points, and the lengthwise points are connected to the lower end of the minor axis like this. Now C3 is extended to D3, C3 dash. So now it is 1, 2, 3, 4, and now these are 1 dash, 2 dash, 3 dash. So C1 dash is extended up to D1, C2 dash is extended up to D2, C3 dash is extended up to D3, and similarly C2 dash is extended up to D2, and C1 dash is extended up to D1. So now you can see C2 dash up to 2, C3 dash up to D3 like this. We will get the points like this. So exactly, we have already one point here, second point, third, fourth point, and then we have D point. So we will get the points like this. Okay. So after getting all these points, join all these with a smooth curve to get the some portion of the ellipse. So repeat all these steps from the bottom portion of this block. Okay. So now repeat the same step to get all this. So to complete the rectangle, whole rectangle. So first we have taken this block, then second we have taken, then third we have to take this, and fourth we have to take this to completely to get the ellipse in the that this method is called the rectangle method. So we are framing a rectangle, dividing the block into 4 blocks, rectangular blocks, similar rectangular blocks. Then divide the height into equal number of divisions, and divide the length of this rectangular block into equal number of divisions that we have done height wise. Then join the upper point of the minor axis to the height points. The length points are connected to the lower end of the minor axis. Then extend these points. So extend these points to get the intersection points. Draw the lines to get the intersection points to get the smooth curve, and that will be the part of the ellipse. And this method is called rectangle method. Now let me move further to see the other method. Now we have the oblong method. The rectangle method and oblong method is absolutely similar. In the case of oblong method, the parallelogram is constructed at an angle of 75 degrees. Then we have to inscribe an ellipse inside that. Now let us see, construct. I read out the problem in this case. Draw an ellipse by oblong method. Draw a parallelogram of 100 mm and 70 mm long, sides with included angle of 75 degrees. Inscribe ellipse in it. This is what the problem. Now similarly construct a parallelogram. Its length is 100 and its height is 75. Then after constructing, then name this as AB. So two perpendicular bisectors AB and CD. In the parallelogram, mark AB and CD. In the parallelogram, constructed parallelogram, consider the first block of this parallelogram rectangular block of this parallelogram, the upper left block of the parallelogram that is also in rectangle shape, and divide the height of this rectangular block into equal number of divisions. Say in this case it is 4. Okay, now divide the length of this rectangular block into the equal number of divisions that we have done in height wise. Then name those points as 1, 2, 3, 4. Then join point D and all the points in the height points. Okay, that you have seen 1, 2, 3, 4. Join 1, 2, 3, 4 to the upper end of the minor axis, that is point D. Then join the lower end of the minor axis to the points of the height on the lengthwise. Okay, so then extend this C1 up to D1, extend C2 up to D2 like this to get the intersection points like this, and join all those points to get the smooth curve, and repeat all these steps to the right side also, and we will get all these points, and similarly repeat all these. We will get the smooth curve like this. We will get the smooth curve like this. This is the oblong method of constructing ellipse in oblong method. The oblong method and rectangle method is similar, but in this case we are constructing the parallelogram. In the case of rectangle method, we are constructing a rectangle. In this case it is 75 degrees here, that you can see. Now let us see another method. This is arcs of circles method. This is also very, very important. Then let me read out the problem first. Major axis AB and minor axis CD are 100 mm. Same. In this case, the major axis is 100 and the minor axis is 75 mm long respectively. Draw the ellipse by arcs of circles method. This method is arcs of circles method. So draw a horizontal line 100 and name those points as AB. Draw two perpendicular bisectors. One is AB and other one is CD. The lengths of AB and CD are 100 and 70 mm respectively. So at one point, so we have one origin. So name that point as O. Okay. So then at a certain distance, so taking AO, okay, taking AO distance, so that means half the major axis. That means AO as distance with C as a center. Okay, with C as center. So we will get one point here. So name that point as F for F1. That means focal point 1. And you will get one more focal point F2. So taking AO distance in our compass with C as center, intersect AB line at F1 and F2. Those 2 points are called focal points. I repeat this. Taking AO as radius with C as center, intersect AB at F1 and F2, F1 and F2. So those points are called focal points, F1 and F2. These are the fixed points. So on line, okay, after getting focus, on line F1O, okay, on line F1O, okay. So taking any distance, so mark the points 1, 2, 3, 4 like this, okay. So, okay, let me read out this once again. So, okay, you mark the points, some points. Okay, you mark on the FO line, so mark some points. So, may not be equal distance, preferably equal distance, but these points need not be equal distance. Mark some points on F1O line. Okay, 1, 2, 3, 4 as of now. Now, taking A1 as radius with A1 as radius with F1 as center. So draw the 2 arcs first. Okay. So you will get, so with A1 as radius with F1 as center, draw one arc. With B1 as radius with F2 as center, intersect the previous arc or previous curve like this. Okay. So we will get one point here. Okay. Then I repeat this, with A1 as radius, with F1 as center, draw one arc here. With B1 as radius, with F2 as a center, intersect the previous arc here. Okay. Then similarly, even the bottom side also, we have to draw the upper arc and the bottom arc similarly, and upper arc and intersect the previous upper arc and bottom arc here. So to get the 2 points, the first point, then take A2 as radius, F1 as center, draw one arc above AB line, draw one arc below AB line. Then B2 as radius, with B2 as radius, F2 as center, intersect the previous arcs. Intersect the previous arcs. Then similarly repeat this step to get the points like this. So after getting all these points, so you can join all these points and name all those points as given and join all those points to get some portion or the quarter portion of the ellipse. So repeat and divide this OF2 also, and repeat this step to get the points like this. Join all those points to get complete ellipse like this. Okay, so join all those points to get ellipse like this. This is called the ellipse by arcs of circles method. Arcs of circles method. Okay. Now let us see the one more method, that is the rhombus method. So in this case, the dimensions are same. Draw the rhombus of 100 mm, 70 mm long diagonals and inscribe ellipse in it. This is what our problem. Now draw a rhombus for the given dimensions. Okay, draw AB line 100 first, then draw the two perpendicular bisectors AB and CD 100 and 70. Then join AB and CD like rhombus. Then mark the midpoints of the rhombus like this. After marking the midpoints, and name those points as ABCD. Name those points as ABCD. Then mark the points like this. Mark the points like this. Join the points like this. Okay. Then you will get the points 1, 2, 3, and 4. You will get the shape like this. And mark these points as 1, 2, 3, 4 like this. Take 1 as center, A1 as radius, take 1 as center, A1 as radius, take 1 as center, A1 as radius, draw AB arc like this. Okay. Then take 2 as center, 2C as radius, then draw CD arc like this. Then A3 as radius with 3 as center, draw AD arc or DA arc. Then 4 as center, 4B as radius, draw this arc. This is very simple method to draw ellipse in rhombus method. This is one of the method, very simple method to draw ellipse. Okay, this is the rhombus method. I repeat this once again. Construct a rhombus with the given dimensions. Those are 100 mm. Construct or draw the two perpendicular bisectors like this. First, perpendicular bisectors, then join all those points, end points, to get the rhombus like this. Then point out mark the midpoints on the rhombus side lines. Then name all those points ABCD as ABCD. Then join the points AB and CD like this. Okay, AB and CD. Then after joining all these points, mark the points 1, 2, 3 points like this. So you take this point as 1, take this point as 2 and 3, and similarly 4. So after marking the points A, B, C, D and 1, 2, 3, 4, take A1 as radius, with 1 as center, draw AB arc like this. With 2C as radius, with 2 as center, draw an arc to connect C and D like this. With 3A as radius, or A3 as radius, with 3 as center, draw an arc to connect A and D. With 4B as radius, with 4 as center, draw an arc to connect B and C like this. Okay, so this completes the ellipse like this. Okay, these are the different methods that we have seen in this slide show to draw ellipse. We have discussed the rhombus method to draw an ellipse. Then we are also discussed the concentric circles method. We are discussed. Then arcs of circles method we are discussed like this, arcs of circles method. Then oblong method we are discussed. Rectangle method we are discussed. Oblong method and rectangle method both are same, except that in the case of oblong method, the parallelogram is constructed at an angle of 75 degrees. But exactly here we have a rectangular block. This is called the rectangle method. Then we are discussed the concentric circles method. Then we are also discussed the general method to draw the this is called the eccentricity method, otherwise ellipse DIRECTRIX-FOCUS method. In turn, we can call it as DIRECTRIX-FOCUS method. That means in this case we are drawing directrix and focus. Then we divided this, the distance between directrix to focus, into the equal number of divisions of the eccentricity ratio. Then we are marking the vertex. Then we are moving the point. We are moving this point vertex in such a way that 2:3 ratio. In this case, the distance, the ratio of distances of the moving point is at a ratio of 2/3. That is, the distance of this point from the directrix, ratio of the distances of this point is directrix ratio to the focus ratio, or focus ratio, the distance of the focus of this point to the directrix. Okay, so this is how we are. We have seen different methods to draw the ellipse. Okay, so with this I close this session. In the next class or the next session, we will see the different methods to draw parabola. In this session, we have seen the ellipse, but in the next session, we will see the parabola, different methods to draw the parabola in the next session. So thank you. Thank you for this session. We will meet you again to discuss the different methods of parabola. Thank you.